Let's make a quick price comparison for M4 lot in US East 1 region. Okay, so US East 1 region has this pricing model. Basically, this price also vary from region to region and time to time. So, uh, when I am recording this video, this is the price in which you can clearly say for on-demand instances there for price type you have to pay $0.10 for M4 large in US East 1. But for spot instances we can get up to 90% off, so that we have to only pay $0.032 to $0.045. And for spot blocks for 1 to 6 hour time period we have to pay per spot price. Okay, but now, like if we have reserved instance, we want to reserve instance for 12 months with no upfront, then we have to pay $0.062. But when we are reserving for 12 months and with all upfront payment mode, then we have more offer as compared to no upfront. So in this manner, if we reserve instance for 36 months, then we get more offer from AWS. And for dedicated host also, here apply only on-demand prices applied for dedicated host. For dedicated host reservation we can get up to 70% off. Okay, so we can, by comparing this chart, we can easily conclude that cheapest one is spot instance, and then after if we reserve instance for 36 months with all upfront or no upfront cost, then we have to pay less. We can basically make a great deal with AWS. Okay, so let's move further and try to understand how EC2 spot instance request work. So by requesting EC2 spot instance we can get up to 90% off as compared to on demand. So here we have to define maximum spot price, and we can get instance while current spot price is less than our set rate maximum price. So here this keyword are purposefully written in zigzag manner so that you can remember that easily. Okay, so the hourly spot price varies based on offer and capacity. Okay, if the current spot price is greater than your maximum price which you set, then you can choose to stop or terminate your instance with a 2-minute grace period. But if you do not stop or terminate your instance, then AWS is going to terminate that. Okay, and other strategy may include like spot block. So basically when we are talking about block, then just block or spot instances for a specified time frame, like time frame may be vary from 1 to 6 hours. So here if we request for spot block, then AWS will not interrupt our spot instances for a specified time frame. Okay, but in some rare situation the instance may be reclaimed. Okay, this is used for batch jobs, data analysis, or workload that are resilient to failures, but it means that can survive to failures. And this type of instance is not so great for critical jobs or databases. Okay, let's talk about EC2 spot instances pricing. So here in this chart you can easily see there is a product which is basically Linux or Unix operating system, and instance type is M4 large, and date range is 3 months. It means this chart is showing 3 months result, and date for this is here given, and on demand price is also here written $0.100, and availability zone and corresponding price is also given here. So here let user defined max price is denoted by this line. Then when you can basically uh, lose your instance, when this price is goes up to your this stated line, then your EC2 instance got terminated. And as per your launch configuration, AWS launch any instance when price of any your set condition availability zone or any of the instance is goes down to your set max price. Okay, so that's it. Let's you can easily see how we can easily request for EC2 spot instances. So you have to first of go into your EC2 dashboard, and now here in instance section you have to click on spot request. Okay, now click on spot request. Now here you can click here either request spot instance, either here. So there is two button available. So here we have two options. We can either manually configure the launch parameters, or we can use a launch template like CloudFormation template. But here first time I want to show how we can configure it. So here I want to launch AMI, which is Amazon Linux to AMI. Okay, and which key pair you want to use. Like here I want to use my AWS SysOps Labs key pair, and here you can also set additional request details, but here I am applying default. Let's explore what are the options we have available here. First of all, I am fleet role. So here you this is a default role for EC2. Okay, so which is already setted here, and here you can also set your max price per instance per hour, but here use default is recommended because AWS know better than we. But here we can also set our max price. Okay, like here 0.085 as per here we can also see the pricing history. Okay, here here our availability, we can select availability zones or per instance type. So here I suppose I choose per instance type, and here you can search for your instance type. Like here I am selecting C5.lodge, and availability zone is here in my lab it is AP South 1A, and here you can also select for date range. Like here you can select for maximum 3 months. Okay, now here you can define your max price. So let's suppose here I define the $0.040 as max price. So first go back here from here by okay. Okay, now here we can set the price as we see by pricing history chart. Okay, so basically this request is valid from this date to this. Okay, here we can also use load balancing, and here we can set target capacity like 1 instance, 2 or 3 or more. Here we can also use either we want to use virtual CPU, either want to use memory. Okay, so here just click on use default because this is recommended by AWS also. Here you can set target capacity, like here for this I want to, and here we can also tick the maintain target capacity, and here you can set interruption behavior like stop or hibernate. So here interruption behavior is, in my case, it is terminate. Okay, So when AWS interrupted our instance, then our instance got terminated. Okay. Here we can also specify capacity rebalance. When a rebalance notification is sent to a Spot instance, it means Spot plate automatically attempts to replace the instance before it is interrupted. Okay. Here we can select also three types: launch before it terminate or launch only. So launch only is set default, and this is good. Okay. So here it launches fleets only for replacement instances and will not terminate the instance that receive the rebalance recommendation. You can terminate the instance that receive the rebalance recommendation, or you can wait until Amazon EC2 interrupts it. You are charged for both instances while they are running. Okay. So always remember these points. Okay. And also, as I already mentioned, when you do lab, then you learn more than the theory. Okay. So here you can set your VPC, and here you can also set your preference availability zone, and here you can also set minimum and maximum virtual CPU which you want in your instance. So here I am setting 0 to like 4, and here memory, yes, 0 to 4. Here we can add also more attribute, like here I want to use CPU manufacturer attribute. So here click on add attribute. Now here we can choose either Amazon, either AMD, either Intel. So here I am choosing Intel. Okay. So here Intel is chooses, and here we have allocation strategy. Basically, three types of strategy are available, but right now we can only choose from two, which is capacity optimized, which is recommended by AWS, and second one is lowest price, in which launch spawn instances from the lowest price instance pool. So here we want to choose capacity optimized or we can also choose lowest price. So here it says okay, fleet strength is strong, okay, for matching instance type and across 3 availability zone, and also estimated hourly price $0.053 per hour at target capacity, and it gives 71% of saving compared to on demand. Okay, now here you can just click on launch. I am not going to launch. I want to just show you how you can basically request Spot instances, because at this time I did not have any use of these instances. I am just showing to teach you how you can easily request your Spot instances. Now you can launch this, but here just we have to move on. I hope okay, here one option is also remaining. So here you can also choose a launch template, like you can use CloudFormation template, Terraform template, or anything like code as a service. Okay, here we can click on, like here I have a my first auto scaling group template. So here I can select this, and here as I already told you how you can request for that, how you can set all these options. Now you can simply click on launch, and here all the material which is basically described in this template is going to created and launch. Okay, so that's it for this video. Let's move further. So let's see how to terminate Spot instances. So in this diagram you can easily see, here we create a request, and this is Spot request with maximum price, desired number of instance, large specification, and request time like one time or persistent, and valid with validation date. So if request failed, then we all know none of the EC2 instance is created. But when our Spot request launches the instance, then it can be interrupted by AWS or a user itself. Okay, so for terminating the spot instances, just we have to follow the some procedure. Like first of all, you always remember you can only cancel spot instance requests that are open, active, or disabled. Like from this flowchart, you can easily see you can only cancel spot instances that is active or open or disabled. Okay, open, active, or disabled. If it is failed, then there is no need to cancel it. Okay, or terminate it. If it is open, then we can cancel it. If it is active, then we can also cancel it. If it is disabled, then we can also cancel it. Okay, and here when we create a request, then it is go to open state, and also after going to open state, it's in active state or into failed state. So when it is failed state, then there is no need to cancel or terminate it, but we can also cancel the open request directly, and also we can cancel the active request. Okay, so when we cancel the active request, so it persistently go to open state, and then it is goes to cancel state. But when we close that, then it is just a one-time process. We can directly close the active request, active spot request, it at one time. Okay. So these are the just a simple flowchart. You can easily understand that. And cancelling a spot request does not terminate instance. So always remember this key point. So cancelling a spot request, it does not mean it terminates the instance. You must first cancel a spot request and then terminate the associated spot instances. It means you have to manually terminate the spot instances. Okay. So I hope you are able to understand. If you are not able to understand, then you can basically you can watch one more time. Okay. So let's talk about spot fleets. So what is spot fleet? Basically, spot fleet is a set of spot instances plus optional on-demand instances. When you use on-demand instances with set of spot instances, then it creates a spot fleet. Okay, the spot fleet will try to meet the target capacity with price constraint. Okay, here we define possible launch pools, instance type, operating system, availability zone, and we can have multiple launch pools so that the fleet can choose. And spot fleet stop launches instance when reaching capacity or maximum cost. And here we have also two types of strategy. Okay, first one is lowest price, and three types of second one is diversified, and third one is capacity optimized. So for lowest price is allocation strategy for spot instances. Here it chooses from the pool with the lowest price, like cost optimization and for short workload. And when we choose the diversified allocation method strategy, then it distributes across all pools, and it is great for availability and long workloads. When you choose capacity optimized, then it pulls the optimal capacity for the number of instances. And spot fleets allow us to automatically request spot instances with the lowest price. Okay, so these are some important points, you can remember that. Okay, let's talk about burstable instances like T2 or T3. About T2 and T3 type of instances. Okay, so burstable instances can be amazing to handle unexpected traffic and getting the insurance that it will be handled correctly. So if your instance consistently run low on credit, you need to move to a different kind of non-burstable instance. Okay, like from these two diagrams, you can easily understand what is the concept of burstable instances. So basically, this is the normal traffic, but when at 210, here a spike in traffic is occurred for very less period of time. Okay, then how our CPU is going to handle this? So basically, at this time, if we are using T2 or T3, then it basically if you are using burstable instance, then it is going to be handled by the CPU credit balance. So here, like here, this is the available credit balance of which is shown in this CloudWatch matrix. So here, when spike is occurred at 210, then here our CPU credit balance is used to handle that traffic. So our CPU credit balance goes down to here. Okay, and then when traffic spike is handled by our CPU credit balance, then after handling this spike, when spike is gone, and now then gradually our CPU credit balance increases. So in this, by the diagram, we can more easily understand the concept of CPU credit. So for like T2 Nano, we have launch credit 30. It means when we launch our T2 Nano instance, then we have already 30 credit, and it supports one virtual CPU and CPU credit in per hour. So when our basically this T2 Nano instance type is constantly running, then it in 3 CPU credits per hour, and maximum in CPU credit balance is 72. It means it can only earn maximum of 72 CPU credit. Okay, and baseline performance CPU utilization is 5%. Okay, so for T2 Micro, launch credit is also 30, and it's work with one virtual CPU, and CPU credit end per hour is 6. So it means it when we use T2 Micro, then it increases the 6 CPU credits per hour until the maximum in CPU credit balance is not reached. So when our CPU credit balance is less than 144, then we end the 6 credit per hour if our T2 Micro instance is running. And also baseline performance for CPU utilization is 10% here. So in this manner you can now understand what is the concept of this table. Okay, so let's move further. So there is a question: what happens when credit are exhausted? Okay, so we can make an experiment. We can run a CPU stress command to peak CPU at 100%, and after the credits are exhausted, the major CPU utilization drops. Okay, so as this diagram show this, but we can as we also learn by using the lab. So let's move on to our lab section and try to understand all these concepts which I discussed here. Okay, so let's log in into AWS console. So type here AWS console. Click on sign into the console, and after entering your ID password, you can get this console. So now we have to go on to our EC2. Now let's see how many CPU credit balance our instance have. So if your instance is running from from 1 week ago, or from 2 weeks ago, or from 1 month or 1 year. So if your instance is not get some traffic spikes. So I think your instance have all the CPU credit balance, your like maximum CPU credit balance. So for seeing our credit balance, we have to go into monitoring section. Now here in last you can see there are two metrics available, which are basically cloud watch metrics. First one is CPU credit usage and second one is CPU credit balance. So if you want to see CPU credit balance, then here we have to go here. So here we are saying there is no any indicator is available. So let's change this. Okay, this is good. Let's set here 1 week. Okay, so here you can easily see that my credit start from, I think as here mentioned already, T2 micro launch credit is 30. So I think when my EC2 instance starts, so we get approximately 30. So here you can see that it's showing 30 exactly. Okay, so here you can also see the time and date when you launch the CPU. So when I launch that, not CPU, when we launch my EC2 instance, then there is only 30 CPU credit. Okay, but after some time it goes to how much? You can simply see that 170. I think now my CPU credit balance is 170 approx. Okay, so here you can easily see that my CPU credit balance. So if you observe it closely, then here it says maximum int CPU credit balance is 144. But here how my EC2 instance has 160 or 170 CPU credit balance. Because of AWS increases this credit balance in last few weeks ago, because when you search here like maximum int CPU balance 32 micro, then here you can see that easily CPU credit balance is 144 credits. But here you can easily see that it's showing me 170 CPU credit balance. Okay, so you can simply conclude this, like here this is saying maximum int CPU credit balance is 144, but when you add this launch credit with this, then you can get approx 172 174 CPU credit. So that's why I think it's showing me the approximately 175 CPU credit balance total. Here you can easily see that from this matrix, but I did not uses this credit. So for seeing the usage of this, you can basically see the different cloud watch metrics of same EC2 instance. Let's click on this, and then click on monitoring, and here you can see the CPU credit usage count. So here let's click on 1 week. So this is the my CPU general credit usage it's showing. So these are the basic spikes in my traffic, I think this spike occurred when I want to install any new software, because my EC2 instance is not running any software. Okay, let's try to understand it by running a stress command. So here let's try to install stress. First of all, we have to connect from our EC2 instance. So here I am already connected, but I have to show you, so that I close window and open a new window. Okay, so here type sudo su and then enter your password. Okay, sorry for that. And then after entering your password, you have to change the directory from where you can directly access your key file. Okay, now here you can use SSH command to connect from your EC2 instance. Okay, now I am connected to my EC2 instance. Now you have to simply install the EPL packages. So for installing this, here you can simply, this command is used. So I already installed it. Okay, so here you have to enter this command and enter here. So it shows me installing EPL. So basically it installing the extra package name is EPL. Okay, now we have to install stress. Okay, into here sudo yum install stress -y command is used. So here first of all let's increase the size. Okay, now here you have to just give the command sudo stress sudo yum install stress -y for clicking yes for all. Okay, so here stress command is installed. Okay, now we have to issue a stress command. So here this is the command which we are going to use. So here sudo stress command which we install by using this command, and here CPU span is set to 8. So here this will spawn 8 CPU workers spinning on a square root task. Okay, and here a parameter is also available, which is -vm byte. So this will use 90% of the available memory from proc memory info. So here you can easily see that this parameter is given here. Now here vm -vm keep command is also used. So this will rewrite or redirty memory instead of freeing and reallocating. Okay, and -m one is used to span one worker spanning on malloc or free function. Okay, if you learn C or any C like programming language, then I think you all aware with malloc or free function. Okay, so let's copy this command and run here. Click enter. Okay, now stress command is building stress on our EC2 instance. So let's watch our matrix. Now we can simply see that how stress is increasing the stress on our CPU. So for saying that, we have to simply go first of all, select your instance, then you have to go on to your monitoring section. Now here first of all you can see the CPU utilization. Okay, let's click on 1 minute. So here you can simply see that now CPU utilization is increasing and it goes up to the 21%, but gradually it increases. Stress command is basically started the making stress. Okay. Now you can easily see that my CPU utilization is go up to 100%. Okay, so here this is approximately showing me 99.6, so it is approx 100%. So let's see our CPU credit balance. Is our CPU credit balance is started utilized or not? So for this you have to go into here. Now go into EC2 dashboard. Now select your EC2 instance. Now go into monitoring section. Now you can simply see the CPU credit balance count. Select here 1 week. So here you can easily see that this started decreasing. Now my CPU credit balance is 166. So basically my credit balance is dropped from how many? Yeah, from 172 to from 172 to 166. Okay, and after some time of this spike, I think it's also decreases more. Okay, now it is 165. So now my CPU credit balance count is started decreasing. Okay, let's see how CPU is utilized. Okay, now our CPU utilization is just got stuck on 100% due to the stress command. So you can simply see that how burstable instances can be used to handle the unexpected CPU stress. Okay, so let's stop the stress command from here, but always remember a point: when your CPU utilization is at 100%, then if you want to give any command from operating system, then you are not able to give that command. Because of that, your CPU is not able to handle that command. Okay, so to manage this type of scenario, you can use the AWS console. Now I have to stop this from my AWS console, this instance. Okay, so go back to your instance. Now you can just stop it from here, or you can terminate it as per your requirement. Okay, I basically want to terminate this command because my purpose for this lab is completed. Okay, so let's terminate this instance. Okay, and let's move on. Okay, what it is saying? Okay, this says me fail to terminate an instance. The instance may not be terminated. Modify is disable API termination. Okay, now go into instance section, click on instance setting and click on change termination protection, and first of all disable it. Okay, click on save. Now you can simply disable or terminate that instance. Now click on terminate. Okay, now my instance state is shutting down, and after few seconds it's got terminated. Okay, so let's move on to our next slides. let's try to understand T2 or T3 unlimited. What is the concept of T2 or T3 unlimited? So basically it is possible to have an unlimited burst credit balance. So you pay extra money if you go over your credit balance, but you don't lose in performance. If average CPU usage over a 24 hours period exceeds the baseline, the instance is built for additional usage per virtual CPU per hour. So we have to be very careful because cost could go high if you are not monitoring the CPU health of your instances. Okay, I hope you are able to understand this very easily because just of hands-on. Okay, so let's talk about the elastic IPs. So when you stop and then start an EC2 instance, it changes its public IP address. Okay, but if you need to have a fixed public IP, you need an elastic IP address. Okay, an elastic IP is a public IP before you own as long as you don't delete it, and you can attach it to one instance at a time, and you can also remap it across instances. You don't pay for the elastic IP if it is attached to a server, and you pay for the elastic IP if it is not attached to a server. So always remember, don't reserve a elastic IP if you don't want to use it. Okay, because of these two points, you have to remember these 2 points. You don't have to pay for the elastic IP if it is attached to a server. Okay, you pay for the elastic IP if it is not attached to a server. Okay, let's move further and talk some more important points about elastic IP. So with an elastic IP address, you can mask the failure of an instance or software by rapidly remapping the address to another instance in your account. You can only have 5 elastic IP in your account. You can ask AWS to increase that. Okay, if this is required, you have to use more than 5 elastic IP addresses, then you can simply ask from AWS to increase that. Okay, how you can avoid using elastic IP? So this must remember these points. So always think if other alternatives are available to you. You could use a random public IP and register a DNS name to it, or you can use a load balancer with a static host name. Okay, these are the some alternatives of using elastic IP. Okay, let's move further and talk about CloudWatch metrics for EC2. As I already make a quick hands-on video on CloudWatch metrics when I am covering the bustable instances. So let's understand more deeply what is the CloudWatch metrics for EC2. So AWS provide metrics, AWS pushes them into metrics basically. So there are 2 types of monitoring is available in CloudWatch. First one is basic monitoring, which is basically default monitoring, and these metrics are collected at a 5-minute interval, and it is usually free. Okay, for detailed monitoring you have to make a payment. It means these are the not free service, you have to pay for it. Metrics are collected at a 1-minute interval or at your defined interval. It includes CPU, network, disk, and status check matrices. Or you can simply push the custom matrix. Basically, it is user defined matrix. Okay, and basic resolution for this type of matrix is 1 minute, and high resolution you can all the way you are free to resolve it in 1 second. It includes RAM, application level metrics, and make sure the IAM permission and the EC2 instance role are correct. Then let's try to understand EC2 included metrics. So first one is CPU. So as I already saw, CPU utilization matrix, credit usage, or credit balance matrix. You can simply also see the networking or network out matrix. You can check the status check like instance status, check the EC2 VM, and system status like check the underlying hardware. And you can also see the disk related matrix, which is generally read, write, arrows, or bytes. These are only available for instance store type of EC2 instances. RAM is not included in the AWS EC2 matrix. So always remember, RAM is not included in AWS EC2 matrix. For this, you have to use the custom matrix type or user defined matrix type. Let's talk about unified CloudWatch agent. So for virtual servers, EC2 instances, on-premises server, you can collect additional system level metrics such as RAM and RAM processes, use disk space, etc. And you can collect logs to send to CloudWatch logs. No logs from inside your EC2 instance will be sent to CloudWatch logs without using an agent. And centralized configuration using SSM parameter store. Make sure IAM permissions are correct, and default name spaces for metrics collected by the unified CloudWatch agent is CW agent, which is also full form of CW agent is CloudWatch agent, and can be configured or changed like in this manner. From this diagram you can simply see that. This is the corporate data center where on the server you can just install the CloudWatch agent, and then this CloudWatch agent say push the metrics and logs which is generally user defined to the CloudWatch matrix. Okay, or you can have also EC2 instances with unified CloudWatch agent, and it also pushes the metrics and logs to the CloudWatch directly. Okay, so let's move further and try to understand some more concept about unified CloudWatch agent. So you can also use a pro-state plugin. This plugin basically collects matrices and monitor system utilization of individual processes, and it supports both Linux and Windows Server, whereas CW agent only supports the Linux. Okay, example like amount of time the process uses CPU and the amount of memory the process uses. You can select which process to monitor by providing this PID file like process ID file, name of process identification number files they create, and by exe process name that match string you specify regex. Okay, by providing the pattern like command lines used to start the process regex. So these are written in zigzag manner because you can, these are the important points so that you can learn it. Okay, and metrics collected by a proc-state plugin begins with proc-state prefix, e.g. proc-state CPU time, proc-state CPU usage, proc-state CPU balance. Okay, etc. Let's talk about EC2 status check. So automated checks is used to identify hardware and software issues, and system status checks are like it monitors a problem with AWS systems, software, hardware issue on the physical host, and loss of system power. And it's also check personal health dashboard for any scheduled critical maintenance by AWS to your instance host. And resolution is like to stop and start the instance or instance migrated to a new host. And instance status check shows the monitor software network configuration of your instance, and like invalid network configuration, exhausted memory, like this. Okay, and resolution for this is to reboot the instance or change the instance configuration. Okay, So this is just a simple example of hardware failure. Now user can stop and start this host 1, or user can simply migrate from host 1 to host 2 to resolve the hardware failure of host 1. So these are the just a very simple thing. Okay, when status check is showing the hardware failure of host 1 to user, then simply what user can do, user can simply just migrate from host 1 to host 2. Okay, so let's move further. Let's understand how we can easily use status check and CloudWatch metrics to recover our EC2 instance. So status check failed may be two types. First one is status check failed system, and second one is status check failed instance, or status check failed for both at the same time. Okay, so we have two options also to recover that. Okay, so first one is recover the EC2 instance with the same private or public IP, or with elastic IP, or with metadata and placement keys. We can also send the dedicated notification using the simple notification service to our admin, so that admin can recover that EC2 instance. Also, there is a second option. We can use simply auto scaling tool, and we can here define set of minimum maximum desired one to recover an instance, but it would not keep the same private and elastic IP address. Like here, this is our EC2 instance, and this is being monitored by the CloudWatch. Okay, then if status check is failed, either status check failed for system or instance, or for both. Okay, it triggers a CloudWatch alarm, and now CloudWatch alarm can send a notification to Amazon SNS topic. Okay, or it can also perform recovery action, and also this CloudWatch alarm can trigger auto scaler. Okay, and option number second is directly using auto scaling group. Okay, now we can simply, when our status check is failed for both or simple one, then we can simply launch a new instance to basically recover that EC2 instance. Okay, let's log in into our AWS account, aws.com. Click on sign in to the console. Okay, now go to an EC2 section. Now here you can just create a launch configuration, or you can just click on auto scaling group. Then you can click on create auto scaling group, give a name, like here auto scaling group 1 SG1. Okay, click and create a launch template. Okay, LT1, give the name LT1. Okay, template version description. Okay, just demo, and here choose the AMI. So here I want to use Amazon Linux, so here I search for just Amazon Linux. Okay, click enter, select your AMI which you want, and here select instance type. Here I want to use T2 micro, so I selected it. Select your key pair name, so here I want to use AWS SysOps Lab, or you can also create a new key pair. Here I want to set up I want to use all default setting of network configuration. So here we can also choose existing security group, or we can create a new security group. So here I am selecting existing one, so here I am selecting default security group. and here I want to use only 8 GB GP2 volume. Okay, so all we done. Click on create launch template. Okay, our launch template is created. Now just go on to your EC2 section. Okay, now we have to click on auto scaling group. Okay, now we can give the name ASG1. Now here we can select the launch template. Okay, so here I want to select LT1 launch template 1. Okay, click on next, select the VPC. Okay, default is already selected, so it is good. Now you can select another one if you want to use. Okay, you can also select availability zone in which you want to create your instances. So here I selected all the availability zones available in my region. Okay, click on next. Now you can also configure the load balancer, but here I don't want to use any load balancer. Okay, we will see in another video. So okay, click on next. Okay, I want my desired capacity to be 2 and minimum capacity be 1 and maximum capacity must be 3. Okay, here we can also choose scaling policy. Here default none is chooses, but I want to use target tracking scaling policy. So you choose a desired outcome and leave it to the scaling policy to add and remove capacity as needed to achieve that outcome. Okay, so which scaling policy name? Target tracking policy. So average CPU utilization, or you can also set it up on average network in or in average network out. So here I want to use it on average CPU utilization. Okay, so here I set up the CPU utilization value 50, or you can also set up it to 70 or 80 or 90. Okay, and here you can simply see that 300 is the 300 second is required for warm-up before including it in the matrix. So here you can also enable instance scaling protection, but I don't want to use, so click on just next. No, I don't want to assign a tag because I just want to show you a just demo. So click on create auto scaling group. Now my SG1 auto scaling group is created. Okay, so you can see it here. Here it's updating the capacity. Okay, now you can see it here. All is done. Now here you can easily see here 2 instance is running here. But if I give the stress command in any of the one, then it's also automatically scale one more instance, so that it can easily handle that all the tasks. So here I set the desired capacity to be 2. Okay, that's why here 2 instances is running and minimum capacity to 1. So here you can easily see the, if you choose the desired capacity up to and minimum capacity to 1, then instance which how many minimum instance will run. So minimum instance will run 2 instances. Okay, why? Because you set the desired capacity. If you don't set the desired capacity, then here only one instance run. Okay, so let's try to increase the stress of this any of the one instance. Okay, so here click on any of the one. So you can just copy the public IPv4 address. Okay, let's copy the public IPv4 address and SSH into it. Okay, change the IP address. Okay, enter here. What? Okay. It seems our SSH request is not able to communicate from our EC2 instance. So let's try to troubleshoot this problem. Okay, so for troubleshooting we have to visit on our AWS EC2 instance dashboard, and here we have to go into security section, and here in security section we have to edit the inbound rules. Okay, so here click on inbound rules. Okay, you can easily see that here SSH port is not allowed, so that it is not able to communicate from our EC2 instance. So click on that, and now click on edit inbound rules, and okay, delete this rule because this rule is not required for this lab. Okay, so here use the what SSH, yes, search for SSH. Okay, just for lab I want to use this. Okay, so click on save rules. Okay, our rules is updated now. Okay, let's try to connect one more time. Okay, sorry for that. Okay, now we are in our EC2 instance. So first of all we have to install the stress command here. So I have to just search for that command, install in stress in Amazon Linux 2 from Well-Architected Framework. Okay, so search for it and go for here, Well-Architected Labs. Okay, now we have to first of all copy this command. Okay, just paste here. Basically this install the extra package which are required in order to install the stress command. Okay, so here now use sudo yum install stress -y for clicking yes. Okay, here stress is installed. Now we want to increase stress. Okay, so let's copy the command for increasing the stress. Okay, here it's started the increasing the stress of our CPU. So just wait for some moments. So here you can easily see after some times when I increases the stress of my one CPU, so it's my auto scaling group automatically started a new EC2 instance. So here you can easily see that here, because of my EC2 instance CPU is not able to manage any request just due to the stress on CPU, which basically we execute here by using stress command. So that here our third instance is also launching. Now here you can see that all the check passed, and here we have all the 3 EC2 instances running here. When we increase the stress on another EC2 instance, so it does not mean it's basically this auto scaling group launch configuration is not able to increase more than this. So when basically we stop this stress command, then our this third EC2 instance is got terminated. Okay, but here we are not able to execute any command due to heavy stress on the CPU. Our this Amazon Linux is not accept any of our command. Okay, like here I want to exit from here. Okay, but here it does not accepting any command due to heavy stress on the CPU. Okay, so let's try to close this, and I hope you understand the basic feature of auto scaling group here. Okay, if I also terminate this instance, then here I will terminate this instance, terminate instance manually. Then when we terminate this instance, here we did not terminated the instance which is in stress. So after some time it will create a new instance due to our auto scaling group policy. Okay, so here we are basically shutting down one of our EC2 instance. Let's try to shut down one more EC2 instance. Okay, so here I am terminating one more instance. Okay, I have terminated the two instances. So let's see what will happen here. Okay, cut here. You will see two EC2 instance is already terminated. One is in past and another one is just a few moments ago, and another one is just shutting down. So due to violation of our auto scaling group policy, our launch configuration and our auto scaling group try to basically launch the more instances here. Okay, so wait for some few moments. Okay, just refresh it. You can easily see here one of the instance is launched here and it is in pending state. Okay, so here refresh one more time, because our desired capacity is 2. Okay, so when this EC2 instance is up and running, then when it feel stress on our first one, then it will launch also the third one. So here it's in running state now. So here it automatically launches this EC2 instance, but after some time it will launch one more EC2 instance. So you can wait for that, but here I am just stopping this lab. Okay, I hope you are clearly able to understand, and you can easily configure the auto scaling group, and you can also able to create the launch configuration. So that's it for EC2. So I hope you are now able to perform all the basic operations related to EC2.